of an easier day. Okay, so all these are rational equations. All it has to be a rational equation has to have a fraction in it. All right, and you have solved rational equations before in your life, anytime you've ever solved a proportion. So not all of these are proportions, but some of them can be written that way. But basically, to be a rational equation, you just got to have fractions within the equation somewhere. So I have a bunch of different examples, different types of rational equations, just to give you some little hints to make things easier to work with. So, very first problem, all right? I've got x over 3, x over 11 equals 42. If you don't have a variable in the denominator, okay, I don't have an x in the bottom of any fraction there, what I would tell you, easiest thing I could ever tell you to do, try to think of a common denominator between the two numbers that you have in those fractions. So what would be a common denominator you could use for 3 and 11? What? 33. Okay, so if you can think of a common denominator between those two, just do me this favor. I'm just going to multiply everything on both sides by whatever that common denominator would be. And think about it, 33, right? So I'm going to think about that as 33 over 1. Because when I've got these fractions in here, you don't do like the top and bottom by 33, because that would be multiplying by 1. So I'm going to multiply the top of everything by 33. If you do that, it should cancel all the fractions out. If you pick something that would be a common denominator between every fraction in the problem. All right, so the first one, I would just have 33x over 3. Second one, I'd have 33x over 11. And then for the 42, I'm going to grab my calculator because I don't know what that is. 42 times 33, 42 times 33 is 1386. Okay, now here's the deal. If you picked what would have been a common denominator between the two and the fractions should just cancel out. So 33 divided by 3, guess what? That's 11. I don't have a fraction anymore. It does have an x with it though. 33 divided by 11, this would become 3x. And then I've got that 1386 because if I multiply everything on both sides by 33 to keep it consistent, we got to multiply that 42 as well. And then this is really the equation we're solving, which is way better than the mess we started out with. So this would just be 14x equals 1386. And I'm just going to grab my calculator real quick, divide 1386 by 14. And this actually ends up being 99. And that's all you have to do. It's not bad. Does anybody have any question about that one? Yeah. So I was just trying to think of a common denominator or a number that both 3 and 11 would go into. If you can think of a number both of those would go into that and you multiply everything by that number, it'll cancel all the fractions that you've got in the problem. So that's really 33. Okay. Let me have you guys now. Okay, there are multiple different ways to solve these problems. I want to try and show you the easiest way to make it less work for you. Okay, so I've got 3 fractions I'm adding, or 2 fractions I'm adding set equal to a third fraction. I do have variables in the denominators of a couple of these fractions. Okay, the easiest thing I can tell you to do is we got to get a common denominator between all 3 of those fractions. Okay, so this one has an a, this one has a 9, and this one has a 9a. What would be a common denominator between all 3 of those fractions? I've got to have an a in it. Anything else? A 9. Okay, so whatever it's missing, just put it in. So this first fraction, top and bottom, I'm going to need a 9. The second fraction, top and bottom, I'm going to need an a. And then each of the third fraction there already has 9a as the denominator, so I don't have to do anything there. Okay, now when you introduce those numbers, you're multiplying top and bottom by that number. So 9 times 6 can give you 54. Bottom is 9a. Second fraction, 4 times a would just be 4a over 9a. And then the other fraction there, the 2 over 9a that was in the original problem, we didn't have to do anything to that. Okay, now, here's the deal. All these fractions have a common denominator, right? If you make all the denominators equal to each other, which they are here, you can literally just cross them out. If all the denominators are equal, all the numerators have to be equal. And so really the equation you're going to solve there would just be 54 plus 4a equals 2. And that's it. And we'll just solve that real quick. Subtract 54. So I've got 4a is negative 52. And then I'm going to take 52, divide that by 4, and we're done. And I did 14 instead of 4. Sorry. Negative 13 here. Okay, let me back up one step because I didn't ask you this in any of the problems so far. So our answer that we get, because some of these can have extraneous solutions, our answer cannot make a denominator 0. This first question, I didn't have any variables in a denominator, so that's not a problem. This question here, if we had ended up getting a was 0, that wouldn't work because it would make a denominator 0 in this problem. We're good because we got negative 13. But just keep that in mind when we're doing the problems. Your answer, if you plug it back into the original problem, cannot make a denominator equal to 0. We're okay so far, but just keep that in mind. Okay. My third problem here, I've got 2/3, 1/4 added together equals 5 over y. Can you guys think of a common denominator between all three of those fractions? 12y. Okay, whatever you need, you're just going to put it in. All right, so this guy, let's see, I would need a 4 and a y, top and bottom. The second fraction, I'd need a 3 and a y, top and bottom. We're trying to make the denominator 12y. And then this one, we would just need a 12, top and bottom. Okay, you can always multiply, so 2 times 4y, this would be 8y over 12y. That second one would be 3y over 12y. And the last one would be 60 over 12y. If all the denominators are equal, it forces all the numerators to be equal, so you just can cross that out and just focus on the numerator. The number that we would not want to get as our answer here would be, we wouldn't want y to be 0 as our answer. That's the only problem number for this situation. So I'd have 8y plus 3y equals 60, which is just 11y equals 60. This one doesn't end up being a nice number, so it's kind of a nasty decimal. I would just go ahead and leave this as a fraction. It doesn't reduce, just 60 over 11. And as long as we didn't get 0 as our answer, we're good. Anybody have any questions? Okay, let's scooch this up a little bit. Now this one, I think this next one is kind of weird. I really only have one fraction the way that problem is laid out. I have c plus 4 over c and then equals 5. Okay, now if I just had, like, if where I have the plain c, if that was a number, I would move that to the other side and maybe deal with it in a different way. But since I got that 4 over c, what I would recommend here, I'm just going to rewrite this real quick. So each one of these is a fraction. So I'm going to write c, keep that 4 over c, and then that negative 5. I'm just going to take the c and the negative 5, just write them over 1 so I can make a fraction. Okay, I'm going to try and make all these denominators match. Then I can cross them out, and we can focus on the numerator. What would be a common denominator between c and 1? Just c. Okay, so this is just a little weird. We're going to do c top and bottom here, c top and bottom here. I don't need to do it to the 4 over c because that already has that as a denominator. Now, this is going to become c times c, so we're going to get c squared. This is going to be a quadratic, but don't worry, it's going to be okay. Then we have 4 over c. On the other side here, I'd have negative 5c over c. If all my denominators are equal, that forces all my numerators to be equal. So really the equation we're going to solve here is c squared plus 4 equals negative 5c. Okay, and I promise if you guys do end up with a quadratic on any of these equations, you will be able to factor it, or if you want to use the quadratic formula, you can always do that. So let me add 5c, and I'm going to put it in between the other two terms there so it looks more like what you guys are used to seeing for a quadratic. So it'd be c squared plus 5c plus 4. And then when I add that 5c to the other side, on the right, that just leaves me with 0 because I canceled all the terms out there, but it still exists. So just go ahead and put that equal to 0. All right, so quadratic formula, if that's your preference, or I would maybe recommend factoring here because it'd be a little bit faster. So what are two numbers you could multiply, get 4, add, to get 5? 1 and 4. So just make one of the factors plus 1, make one of them plus 4. What would my actual answers be? -1, -4. And then just real quick, just check. The only problem number we would have here would be if C was 0. That's the only thing that would make a denominator 0. So both of those answers will be solutions for that equation. Okay, does anybody have a question? All right. Here is what I would recommend with this one. If you don't have variables in the denominator, right? I've got two denominators here. One's a 2, one's a 3. Try to think of a number both of those would go into, or think of a common denominator between those two numbers. What's a good number that 2 and 3 would both go into? 6. Okay, just do me one favor. Just multiply everybody on both sides by 6. Now, you got to remember, it's got to go in the top of the fraction, and that will get rid of the fractions. So here's what I'm going to do. For that first one, I'm going to do 6, and then I'm going to put that x plus 3, just put that in parentheses. We'd have the 2 on the bottom. Second fraction, again, I'm just going to put that 6 out in front. X minus 20, put that in parentheses, 3 on the bottom. And then on the other side, it's just 3 times 6, so that's just going to give you 18. Okay, now if we picked a number that both of those denominators go into, which we did, that's just going to get rid of these fractions. So I have a product here. 6 times this, 6 over 2 you can reduce. So this would be 3. We're still going to use a distributive property, but instead of being 6 over 2, I'm just going to reduce that to 3. Here, 6 over 3, this has got a subtraction sign in between, we'll just have 2. We still have the x minus 20, but this is a whole lot easier to work with than that problem we started out with. So just a little distributive property here. So 3 times x, you got 3x. 3 times 3 is 9. Now, since I'm subtracting in the middle, what I just do there, just distribute that as a, bless you, as a -2, and then you're good. That takes care of that subtraction sign. So -2 times x, -2x. Now, -2 times -20 is going to turn into a positive 40. And then I've got this 18 on the other side. If you guys go ahead, combine your like terms, 3x and -2x, this will just give you an x, just one x. 9 and 40 will give you 49. And I would just have one more step at that other side of that equation equal to 18. Just move the 49, it's positive, so I'm going to subtract it. And don't judge me, I'm using my calculator. It's -31. And nothing would have caused us a problem as a restriction for that question, because in the original problem, you never had a variable in any denominator, so you don't have to worry about your answer there. Okay. Now, and it's just going to kind of depend, so you're going to have to decide what you want to do. On this question I've got here in the back, I've got 6 over y plus 1, 5 over y minus 2. You can create a common denominator between the two of these on each side if you want. It would literally be the same action, though, as just solving this like a normal proportion. So I would just solve this like a normal proportion. So I'd have 5 times y plus 1. Just be careful when you do the cross products, if they're diagonal from each other and they've got a couple terms, you got to distribute. So then the other cross product, you'd have 6 times y minus 2. And then however you guys want to do this, I'm just going to do a little distributive property. I've got 5y plus 5. We got 6y minus 12. If it's me, I like to keep my variable positive. So I would subtract 5y from both sides. And I'm just going to do this in the same step to save a little space. I'm actually going to add the 12 to the other side in the same step. So I'm going to have 17 for my two numbers, and 6y minus 5y is actually just 1y. So then my answer would be 17. And I would just check real quick. In the original problem, I have y plus 1, so -1, we wouldn't want that as an answer. And I have y minus 2, that's in the other denominator. 2, I wouldn't want as an answer, but we're totally fine because we didn't get either one of those numbers. Okay, now, go ahead. This one? Do what now?
Instead of 49, would it be 31?
They're both positive. Yeah, because you did a minus a negative here, so that ends up being positive 40. So positive 40, positive 9. Yep. Good question. Okay. Does anybody else have any question? I feel like I'm going really fast. Okay. Now, here's the deal. I can cross multiply this right now, yeah? But if I do that, I'm going to have a quadratic here. So maybe if I think it's going to take me a little bit of time, we could do that. I know you know how to do it. But do you notice anything about these two fractions before we start? They have the same, do you guys see they have the same exact denominator? Okay, well guess what? Just like the ones on the front, if they have the same denominator, then that forces the numerator to be equal. So really all I have here is y minus 2 equal to 4. You could do cross products, solve a quadratic, get it, and then there would be two answers, and I'm going to show you in a second here. If I just add 2, my answer is 6. Can I have that as my answer? This is the one question on here. This has an extraneous solution. This would cause your denominator to be 0 on both sides of that equation. So this question actually has no solution. If you had gone through and done cross multiplication, solved that with a quadratic, which you can do, both of the answers, it actually ends up being y minus 6 squared. But both of the solutions are going to be extraneous there because it would make that denominator 0. So if your answer makes a denominator in the original problem 0, just say, okay, we don't have a solution. All right. Now, this guy right here, the denominators don't match. Really, the reason I put this problem on here was because I think people get tripped up with, if I have a negative here, like what do I do with that? So I feel like a lot of time people put it on the top and the bottom of the fraction. But if you do that, you'd have a negative over a negative. That would actually cancel out and be positive. So here's my recommendation to you. And you can do whatever you want. You can attach it to the top or the bottom. I usually just attach that negative to the top. So that way I'm not using it in both parts of the fraction and it wouldn't cancel out. So just attach that negative either to the top or the bottom of that fraction. If you put it with the bottom, you have to distribute it to the a and the 15. So I'm just trying to take the path of less work by putting it with the top. Now, honestly, common denominator here, if I got that between the two, it would be the same amount of work as just cross multiplying this as a normal proportion. So I'm just going to go ahead and do that real quick. So we're going to have negative 3a times a minus 9, one of the cross products. The other one, you're going to have 3 times a plus 15. This is going to end up being a quadratic, but don't worry. It's going to be factorable. So I'm going to get negative 3a squared minus 9. Oh, no, fail. Minus 27a. And then on the other side, I'm going to get 3a plus 45. Yes, you're totally right. Plus 27. Negative 3 times negative 9. All right, now, if it's me, I'm going to try and factor this. If you want to try and factor it, you want your squared term to be positive. So in this situation, to set this equal to 0, what I would do, I'm going to tell you, let's add the 3a, and then I would subtract the 27a to the other side. So I'm going to add 3a squared, subtract 27a to this other side. So we would just have 0 left on the left side. 3a squared, nothing to combine that with, but it's going to become positive, which will be nice for us. Okay, now with the a's, I had a positive 3a minus 27a, so I'm going to have minus 24a's if I combine those like terms. And then I just had a plain 45 and no other plain number. Now, before I do this problem, before I try to factor or use quadratic formula, do you guys notice, do all these terms have something in common? We have 3a squared, 24a, and 45. What do you think? They're all divisible by 3. Okay, now, because this is an equation, I don't have to factor this out in front. I can actually divide every single thing, including the 0, totally legal to divide 0 by a number. Just get rid of that 3. So we'd be left with a squared minus 24 divided by 3 is 8a, and 45 divided by 3 is 15. Now, I promise you, if you end up with the quadratic, it'll be factorable, or you can use the quadratic formula. Could you guys think of two factors that would multiply, give you 15, add to give you -8? 3 and 5. They just both have to be negative. So -5 times -3 gives you the positive 15. -5 plus -3 gives you the -8. What are my actual answers? 5 and 3. And then just real quick, like if I was doing this on a test or quiz or whatever, before I write that on the line, just look back here. Problem numbers for us would have been -15 or +9. I didn't get that for either one of these, so both of these answers will work. Okay, now I have one more. This one's probably the hardest problem on the whole thing. So I have 3 different fractions here. 2 of them do have a common denominator, right? So what I would recommend here, I'm going to try to make a common denominator between all 3 of these fractions. But before I do that, let's just do a little factoring like we've been doing to simplify some of these problems to see what we need or don't need in each fraction. So 2y minus 8 in the bottom of that first fraction, I could take a 2 out in front of that, and left over I'd have y minus 4. The fraction in the middle there, 7y plus 8, you're not doing anything with that, so I'm just going to leave that alone. But I've got y squared minus 16. That is a difference of squares. Can you think of 2 numbers when you multiply them, you get -16, they add up to 0? Yes. Okay, so one is y minus 4, one is y plus 4. Okay, and then the fraction on the other side, that would actually just factor identically to what I had over here, right? Because it's got the same thing, so I'm going to do 2 times y minus 4. Okay, now I'm going to put in whatever I'm missing. So both of these fractions have a 2. This one in the middle does not. So I just need a 2 top and bottom here. All 3 of these fractions have a y minus 4, so that's good. The one thing that I need to include, I have a y plus 4 here. I need it in both of these 2 fractions. All right, so I'm going to need y plus 4 here, top and bottom technically, and y plus 4 here. Then all my denominators are the same. All the denominators have a 2, they have a y minus 4, and they have a y plus 4. If you make these all match up, which I just did by doing that, this is a little complicated, but it's going to save you so much time. If all the denominators are the same, then it forces the numerators to be equal. Now, the numerator of that first fraction is 10 times y plus 4. I'm just going to put the 10 out in front, make it a little easier to look at. Then I have minus. We did not, oh yes we did. We had to put a 2 here, sorry. 2 times that 7y plus 8. And then on the other side, I had -8, and we had to multiply that by y plus 4 to create that common denominator. Now, this is a little bit much because it's a bunch of distributive properties, but it's way better than dealing with a quadratic or something like that, if that can be avoided. So we're just doing distributive property here. You're going to get 10y plus 40 minus 14y minus 16. And then on the other side equals -8y minus 32. I know it's long, but just however you guys want to solve this, it's totally up to you. Let's see if I can scooch this up so I have a little bit more room on the paper. All right, if it's me, I'm just going to combine like terms real quick on the left side here. So I've got -4y, 40 minus 16 is 24. On the right side, I just had that -8y minus 32. I didn't have any like terms. Okay, if it's me, I like to try to keep my variable positive if I can. So I would add 8y to both sides. And just because I'm writing too big, I'm going to do this right in the same step. That's going to cross this out. So then I'm actually going to subtract 24 to the other side. Just do that right in the same step. That'll put all my variables on the left and all my numbers on the right. -4y plus 8y will give you 4y's. And then -32, -24 is -56. And then all I have to do there real quick, divide by 4. And it would be -14 as my answer. And if you look back to the original problem, we would not want our answer to be 4 or -4, which is not what we got, so we don't have an extra solution here or anything. This is the answer. Is anybody having a question? Okay, my best recommendation to you, just get a common